Hello folks, and welcome to our next lesson. This is sections 2.3 and 2.4, which are, we're going to just call these linear equations. I'm going to be covering a lot of topics today regarding linear equations. So, let's get started by talking about slope. Now let's say you were going on a bike ride and your friend said, oh yeah, I have this great hill that I want to take you up. Well, if he's taking you up a hill, there's two things you might want to know. You might want to know how steep the hill is and how long the hill goes for. And so these are what covers our slope. Our slope is the steepness of our line. Or in other words, our slope is our rise over our run, or our change in y over our change in x. Now we have four main types of slopes here. The first one we have is positive. Remember, when we're looking at these, we always go from left to right. So positive is going from left to right, we increase. We have our negative, which is going from left to right. We decrease, our rise is downward. We have zero, which means going from left to right. We don't change our rise at all. And then we have undefined. And undefined means we don't go left to right, which is why it's so confusing. Undefined means we go up and down. Now remember, we'll come back to this in a little bit, but we have a couple of special equations that we use when we have zero and undefined slopes. Now how do we determine our slope? Well, we said our slope is our rise over our run. So if we have a graph, we look for 2 points like this one and this one. We say, how much are we rising or falling? Well, we go down 1, 2, 3, 4. So we go down 4. And then we go over right. How far do we go over right? Well, we go 1, 2, 3, 4, 5, which means that we run 5. And we get our slope, which we use the variable m, is going to be our rise over our run, or our slope is going to be negative 4 over 5. What would the slope be for this one? There are 2 points. For this one, how much are we going up? We're going up 1, 2. So our rise is 2. How far are we running? We go 1, 2, 3, 4, 5. So our run is 5, making our slope equal to 2 over 5. So remember, rising over run. Our slope, if we're dealing this with points instead of dealing with the graphs, we said it's rise over run. But what is rise? Our rise is our change in y over our change in x, right? Run is how much we're changing in x. Rise is how much we're changing in y. And when we're changing, all we're doing is we're looking at one number, the bigger number, and we're seeing what the difference is to the smaller number. Making our formula for slope, if our change in y is y2 minus y1, that's our change in y, then we divide that by our change in x, which is going to be x2 minus x1. Now remember, it doesn't matter which point you choose as x1 and y1 or x2 and y2, you just need to be consistent. So when we're practicing for something like this, we'll choose this to be point 1, this to be point 2. And then all we have to do is we say, well, our slope is going to be y2, which is 11, minus y1, which is 1, divided by x2, 8, minus x1, or 2. Then we simplify. So 11 minus 1 gives us 10 over 6. Now don't forget, this isn't complete. Why is this not complete? This is not reduced. We have a factor of 2 that we can take out of both the top and the bottom. So 10 divided by 2 gives us 5 over 3. What would our slope be for this one? If we choose this point to be 1 and this point to be 2, what do we get? Well, we get y, or m, is equal to y2 is 3 minus y1 is 7 over 6 minus 1. 3 minus 7 gives us minus 4, and 6 minus 1 gives us 5. So our answer is minus 4 over 5. This one is a little trickier just because we have to keep track of negatives. And we'll call this point 1 and this point 2. Our slope is then going to be y2 minus 4 minus 5 over x2, 7, minus x1, minus negative 2. So negative 4 minus 5 gives us minus 9. For 7 minus 2, minus a negative is the same thing as plus a positive. So this is 7 plus 2, or negative 9 over 9, which we can reduce to minus 1. Our key concept when we have this slope is our slope-intercept form. Should be familiar, our slope-intercept form is the form y is equal to mx plus b. We already said m is our slope, and b is going to be our intercept from the name. B is specifically going to be our y-intercept, which is where x equals 0. Now we can write the equation of a line given a couple of different things. First of all, if we have a graph, what do we need for a slope-intercept form? Well, for slope-intercept form, we need a slope and we need an intercept. So let's try to figure those out. What's m and what's b? B should be pretty simple. We look, we see our y-intercept right there. So b is going to be 3. What is our slope going to be? Well, let's choose 2 points to look at. We already know that's a point that we can use. Where's another point that this goes through? Looks like we have a point all the way down there. And now we figure out how much we're falling over how much we're running. So how far do we go down? 1, 2, 3. So we go down 3, and we go over 1, 2, 3, 4, 5. So we go down 3 over 5, making our slope minus 3 over 5. Now what did we need for this? We needed our slope and we needed our y-intercept. Y and x we keep as variables, meaning that all we have to do is we substitute these values in. And we get y is equal to negative 3 over 5x plus 3. How do we do this if we have a point and a slope? Well, what do we need for slope-intercept form? We need m and we need b. We don't have b though. So what are we going to do? Well, let's just try to do what we know how to do. Let's put in m because we know what it is. We know y is going to be equal to m, which is negative 3, x plus b. And now we're stumped. We're saying, how do we get b? Well, we have an ordered pair here. What does an ordered pair represent? It represents x comma y, meaning that we can substitute these two values in. 8, or y becomes 8, and x becomes 2. We can simplify this out and find out that b is going to be equal to, what is that, 14. So now we have m and we have b. So we can just write this out as y is equal to mx plus b. So pretty simple here. What about if we're given 2 points? Now this one's harder. We don't have m and we don't have b. We have 2 points though. What do we know that we use 2 points for? We look back up, we see we have a formula for slope that uses 2 points. So let's mark these points. We'll call this one 1 and this one 2. We know then that our slope is going to be equal to y2 minus y1 over x2 minus x1. Or this is going to be 11 minus 5 is 6. Minus a negative is the same thing as plus a positive. So this is minus 6 over 3 or 2. Great, now we have a slope and we have 2 points. What do we do from here? Well, from here we have a slope and a point. So we can just follow this. We know what our slope is, so let's put that in and see what we can do. Left with y is equal to 2x plus b. Now we're stuck again. But we see we have these points, so let's substitute in one of those. We know y is going to be 11 and x is going to be 1. And now all we have left is b, so we can solve for it. Subtract 2 and we get b is equal to 9. So now we have our slope and our y-intercept, meaning that we can just put these into the equation. Get y is equal to 2x plus 9. Right? That's how we solve for point or slope-intercept form each of these three different ways. Now let's move on to graphing lines. What are our steps for graphing lines? First step is we need to get this into slope-intercept form. So we need to get this into y is equal to mx plus b. For this, what are we going to do? I'm going to work on this here. We need to subtract 3x from both sides. So we get 2y is equal to minus 3x plus 10. Now this isn't y is equal to mx plus b because we have this 2 out in front. So we need to divide everything by 2. And we get y is equal to minus 3 over 2. We can split up the fraction. So we get minus 3 over 2x plus 10 over 2 is 5. So we get y is equal to minus 3/2 x plus 5. Great, now we're good to go. Step 2 is going to be plot your y-intercept. So for this, we're going to plot our y-intercept. What's our y-intercept? B is 5, meaning we go to 0 and we go up 5, and we mark a point. Step 3, we're going to plot some more points using our slope. More specifically, we're going to plot at least 2 more points. So we'll do this by using our rise and our run. How much do we fall? We go down 3, so we go down 1, 2, 3. We go over 1, 2. Then we go down 1, 2, 3. We go over 1, 2. And then step 4. This is super hard. We're going back to kindergarten here. We're going to connect the dots. And when you're connecting the dots, use something straight. Use something that has the ability to make straight lines. Unfortunately for me, that is hard to do on a computer, but I'm going to do my best here. All right. And we connect the points as straight as possible. And that's how we graph. Great. Now, we're going to graph this one. I'm going to have you figure out what it is in slope-intercept form. So what is this in slope-intercept form? Right, what do we need to do for this one? Well, we need to subtract 5x. We need to get this into y is equal to mx plus b. So we get rid of the 5x, bring that over to the other side. And then we're going to divide by this negative 2. That's going to leave us with y is equal to negative divided by a negative is going to give us a positive. And then 12 divided by negative 2 is going to give us minus 6. We go to our graph. We go all the way down to minus 6. And then we plot our points. So we go up 1, 2, 3, 4, 5 over 2. We go up 1, 2, 3, 4, 5 over 2. And then we draw our line. What about for number 2? Well, we need to get this into y is equal to mx plus b. From this, we can tell that we have no x. So what is this going to be? Well, if we look at this, we could write this as y is equal to 0x plus 3. And this will help us explain it. So now we know m is 0 and b is 3. So we go to 3. And this is where we have 0 slope. So we rise 0 over however much run we have, or in other words, we get a horizontal line. And this is where we get back to the very first page here, where we're talking about our different slopes. For a 0 slope, this is where m is equal to 0, meaning our answer will be y is equal to a number. And undefined is going to be the opposite. It means our slope is infinite. So the way we write this is x is equal to a number. We're going to scroll back down and get to point slope form. So we talked about how you deal with making something into slope intercept form when you have a point. But we can do this in a little bit easier way using point slope form. And point slope form says y minus y1 is equal to mx minus x1. Or what this is this is y is our variable, x is still our variable, m is still our slope, and then we have 2 points. So this is y minus a point is equal to our slope times x minus a point. And you might think, wow, this is confusing, but it's actually really simple. It just comes from our slope. We said our slope is equal to y2 minus y1 over x2 minus x1. Now, what if instead we just said, well, we don't want to look at 2 specific points, so let's just say we're going to look at any point y, but we're still going to look at y1, and we'll look at any point x, but we'll still look at x1. So now instead of having a second point, we're saying we'll choose any second point we want. Well, what happens then? Now, how would we solve for this? We can multiply both sides by x minus x1. And what are we left with? Well, this side, those two cancel out, and we're left with y minus y1. What's over on the other side? Well, we have m times x minus x1. So this is a handy tool to have at your disposal. For example, if we have something like this, we can take this from point slope form into slope intercept form. With this, we have x1, we have y1, and we have m. So using this equation, this becomes y minus, what's y1? It's 8, is equal to m, which is negative 3, times x minus, what's x1? Is 4. So what does this come out to be? We get y minus 8. We're going to distribute the minus 3 in. So this is equal to minus 3x plus 12. And look, we're pretty close to slope-intercept form. All we have to do is add that 8, and we're left with y is equal to negative 3x plus 20. So this is a useful step for skipping some of the pain. It's also handy when we're dealing with 2 points, because we can find our slope. Let's call this point 1 and this point 2. So this becomes y2, or 15, minus 6, over 4 minus 1, which is the same thing as 15 minus 6 is 9 over 3, so m is 3. Great. Now how do we do this next part? We have a point, or we have a slope, and we have 2 points. Let's choose the easier point. I don't want to work with a number like 15. So let's instead choose this. So what we're going to do is we're going to put these all in. So this becomes y minus y1 is going to be 6 is equal to m, which is 3, times x minus x1, which is 1. Now we distribute this in, and we're left with y minus 6 is equal to 3x minus 3. From here, all we need to do is add that 6. So we're left with y is equal to 3x plus 3. Now we have a couple of examples. I want you to put both of these into slope-intercept form using point-slope form first. So for this, what's our point-slope form going to be? Well, this is x1, this is y1, and this will become y minus 3, which is y1, is equal to m, or our slope, times x minus x1, which is 8. Distribute this in, we get y minus 3 is equal to 1/2 x minus 8 over 2, or 4. We add the 3, and we're left with y is equal to 1/2 x minus 1. Now go ahead and try this one. How do we start this? Well, we start by finding our slope. We'll call this 1, this 2. So our slope is y2 minus y1 over x2 minus x1. Made a mistake there. So this is not y1, this is x1. Make sure you're not making silly mistakes like I just did there. So what is y1? It's 1. Now we can simplify this. So 2 minus 1 is 1. 8 minus 6 is 2. So our slope is 1/2. Now where do we go from here? Well, we have a point. Let's use this one. It has smaller values. And we have a slope. So we do y minus y1 is equal to m times x minus x1. Distribute this in. We get y minus 1 is equal to 1/2 x. How did I do that? x1 is 6 minus 3. Add that over, we get y is equal to 1/2 x minus 2. So there is our answer. Okay, what about if we had something like this? Well, this makes our life easier because all we need to do now is we need to find the slope. And what's our slope? Well, we rise up 1, 2, 3, 4, 5, 6. We go over 2. So our slope is 6 over 2, or 3. And now we're just going to pick one of these points. Let's use this one because I covered that one up. So this is going to be y minus 3 is equal to, what's our slope? 3 times x minus 1. Minus negative becomes plus positive. We distribute this in. We get y plus 3 is equal to 3x minus 3. Or we get y plus, subtract the 3, so this becomes y is equal to 3x minus 6. So y is equal to 3x minus 6 is our slope-intercept form. And this right here would be one of a number of possible point-slope forms. So y minus 3 is equal to 3 times x minus 1. Great. Now we have one last form to cover, which is standard form. Now what are two characteristics that we will always have for any? Let's say our slope's hard to figure out. We have 2 points that we should always be able to figure out. One is right there, and one is right there. So we can use our x-intercept, and we can use our y-intercept to form the equation of a line. Remember, the y-intercept is where x is equal to 0, and our x-intercept is where y is equal to 0. So what's our equation for a standard form? It's some number a times x plus by is equal to c. Now this is the most annoying one, but it's actually sort of handy. And let's show you why when we get to graphing. For graphing in standard form, what do we do? Well, step 1 is going to be set x equal to 0. Then what we can do is we can solve for y. This will give us the point 0, y, or our y-intercept. So let's do that for this one. We get 2 times 0 plus 3y is equal to 6. This becomes 0, and we're left with 3y. Divide by 3, we get y is equal to 2. So that becomes the point 0, 2. Next thing we're going to do is we're going to set y equal to 0 and solve for x. This is going to give us the point x, 0, or our x-intercept. So this time we get 2x plus 3 times 0 is equal to 6. You can cancel that out. Left with 2x is equal to 6, or x is equal to 3. So this gives us the point 3, 0. Perfect. Now we have 2 points, so what we're going to do is plot those points. So we'll go to 0, 2, 0, 2, and we'll go to 3, 0. And all we need to make a line is 2 points, so we're going to connect the dots. And again, you should be using a straight edge or a ruler so that your lines come out better than mine. Right, we did one similar to this, so we're just going to jump straight ahead and look at this one. For something like this, what do? Our first step is to set x equal to 0. So when x is equal to 0, we get that this is 1/2 y is equal to 1. How do we get rid of this 1/2? We have to multiply by the reciprocal. So we multiply by 2 over 1. Multiply by 2 over 1. And that gives us y is equal to 2 over 1, or 2. So this tells us we have the point 0, 2. Now let's set x, or we already set x, let's set y equal to 0. What is that going to give us? That's going to give us 1/3 x is equal to 1. Again, we're going to multiply by the flip of this fraction, so 3 over 1, 3 over 1, and that's going to give us x is equal to 3, or the point 3, 0. So now we can go through and we can say, all right, we'll go out to 3, 0, we'll go out to 0, 2, and draw a line through those. Great, now why would we want to use this over any of our other forms? The other forms are nice and simple. If we have a slope and we have a point, everything goes really easily. Well, let's say we have something like this. You're going to the carnival, apparently this was last year, and it's $2 per child and $4 per adult. You want to figure out the number of children and adults that you could bring in if you had $12 to spend. So, if we call x our number of children that we're going to bring in, children, swear I can spell, and y is our number of adults, then how much does it cost per child? It costs 2 per child, and it costs 4 per adult. And that's equal to $12, all we have to spend. So some of the times when we're modeling, this is the more natural way it'll show up. Now, let's do this again. Set x equal to 0. We get 4y is equal to 12, or y is equal to 3. Then, let's set y equal to 0. And what do we get? We get 2x is equal to 12, or x is equal to 8. And now instead of using a graph like this, we can say, perfect, we already have everything we need. So we can say our x-axis is going to be our number of children we get in. Our y is going to be our number of adults. When we mark these out, 1, 2, 3, 4, all the way down to 1, 2, 3, 4, 5, 6, 7, 8. And we can say, well, we know we can bring up to 8 children in, and we can bring up to 4 adults in. We can choose anything on this line. So we can choose any number of these. If we go to here, that looks like a point that might be on the line. We could bring that number in. So this is why it's useful. Right. Let's look at some review. What are some of the benefits and downfalls of using each of these methods? Slope-intercept form. Well, it's good old trusty. We know how to use it. But it's hard to use when we have 2 points, or when we don't have the y-intercept. Point-slope form is slightly harder to use, but what's the nice part? It already puts it into slope-intercept form for us. And we can do it with any point. Right, and what about standard form? Well, if we have super big intercepts, it's nice. But it can be a pain to use. So there we have it, 3 different forms of linear equations. Let's go ahead and get started on your homework.